Hey folks, welcome back to Bazai. Today's system design refresher breaks down TCP versus UDP using a clean mental model, accuracy or speed. Every packet on the internet makes that trade-off, and understanding it helps pick the right protocol for web apps, streaming, games, and AI agents. What is TCP? TCP is connection-oriented. Before data flows, there's a three-way handshake to establish a session, synchronize sequence numbers, and agree on options. That setup lets TCP deliver bytes in order, detect loss, retransmit missing segments, and remove duplicates. It also implements flow control, so a fast sender doesn't overwhelm a slow receiver, and congestion control, so one host doesn't flood the network. The cost: a bigger header and more coordination, which adds latency and CPU overhead. Use cases: web browsing, emails, file transfers, database replication, any workload where correctness beats speed. What is UDP? UDP is connectionless. There's no handshake, no session state, and the header is tiny. The sender just fires off datagrams. There are no guarantees of delivery, order, or duplication control, and there's no built-in flow or congestion control. The benefit is minimal overhead and lower latency. Use cases: real-time voice and video, multiplayer gaming, live streaming, DNS lookups, scenarios where freshness matters more than perfect reliability. Service targets and addressing. Both TCP and UDP support unicast, one sender to one receiver. UDP also commonly supports multicast and broadcast patterns for group delivery, which is useful for service discovery and real-time distribution on local networks. TCP generally sticks to unicast streams that maintain reliable, ordered delivery semantics. Header size at a glance. A plain TCP header without options is 20 bytes, and it can grow with options like timestamps and window scaling. The UDP header is a fixed 8 bytes, source port, destination port, length, and checksum. Smaller headers mean less overhead per packet, which is why UDP shines when every millisecond counts. Reliability versus best effort. TCP's reliability pipeline handles sequencing, acknowledgements, retransmissions, and in-order delivery. If a segment goes missing, TCP notices and resends before handing data to the application. UDP is best effort. Packets may arrive late, out of order, or not at all. Many real-time apps implement their own logic on top of UDP. Jitter buffers, forward error correction, selective retransmissions, only when needed, keeping latency low. Flow and congestion control. TCP dynamically adapts its sending rate. Flow control uses the receiver's advertised window, so the sender never pushes more data than the receiver can buffer. Congestion control algorithms, like slow start and congestion avoidance, probe available bandwidth and back off on loss to protect the wider network. UDP has no such mechanisms by default. It will keep sending as fast as the application dictates, which is powerful but risky without sensible rate limiting.